Hello students, we have learned about Venn diagram in the last session. So we'll start with few concepts related to Venn diagram. So consider this diagram. Universal set is given, A is given, B is given. According to the statement, B is the subset of A. As I said earlier, universal set is indicated by a rectangle. Other sets are indicated by the circles. So here the purple diagram, that is rectangle, shows the universal set. It contains 2, 4, 6, 8, 10. Now see here in the diagram, set A is indicated with the brown. So it includes 2, 4, 6, 8, 10. But if you observe B includes 4 and 6. So if you compare A and B has the common entry, that is 4 and 6. So consider the smaller set, that is B now, with the elements 4 and 6. A superset to B actually. A includes, along with 4, 6, 2 is there, 8 is there, 10 is there. So if you consider this full diagram now with 2, 4, 6, 8, 10, that comes under set A. Suppose if you put all these two inside a rectangle, then that considered to be the universal set U. If you observe the diagram, see here, this region, that is B now, B is the subset of A, outer set is A. If you observe again, this A is a subset of U. A is the subset of U. Now we'll consider second one. This is the diagram for union. Consider two sets A and B. If you consider the union of those two, see here, union of A and B, the shaded region indicates A union B. Suppose A and B has no entrance in common, then you have to draw two disjoint circles. Here two non-intersecting circles actually, but you have to shade both the circles to get the union. So this indicates A union B. This also indicates A union B when they have the intersection elements. Consider A intersection B now. So consider two sets A and B. This green region indicates A intersection B. If they don't have any intersection, then they are called disjoint sets. Intersection is null set. Now consider few formulae based on the diagram. Consider the diagram. Three sets are there. Suppose if you consider this as A, this as set B, this as set C, third circle. Then consider intersection of 2 to each. A intersection B intersection C, and A intersection C. So this green region indicates intersection of all the three sets. A intersection, B intersection, C. Green region indicates intersection of all the three. A intersection, B intersection, C. Okay. So this one indicates A only, this one B only, and this purple region C only. Now consider few formulas based on this diagram. N of A only means cardinality of A only. That is N of A minus N of A intersection B minus N of A intersection C plus N of A intersection B intersection C. Now listen to me. We have considered two formulas in the earlier class. That is N of A union B equal to, when two sets A and B are given, N of A union B equal to N of A plus N of B minus N of A intersection B. If we consider three sets, N of A union B union C, this is equal to N of A plus N of B plus N of C minus N of A intersection B minus N of A intersection C minus N of B intersection C, and finally plus N of A intersection B intersection C. So this is the formula when three sets are given. So based on this we can calculate all this. Consider second one now. N of at least 1. Among these three, N of at least 1 means N of A union B union C. That gives you same formula. N of A plus N of B plus N of C minus N of A intersection B minus N of B intersection C minus N of A intersection C plus N of A intersection B intersection C. Remember, last term is positive. Consider third one, N of exactly 1. The formula is N of A minus B union C plus N of B minus A union C plus N of C minus A union B. Or you can use this also. Fourth one, N of exactly 2. N of A intersection B plus N of B intersection C plus N of A intersection C minus 3 times N of A intersection B intersection C. Means this region, green region, you have to delete 3 times. Last one, N of none, not belonging to any of this. N of A union B union C, complemented this. From the universal set, that is N of U, you have to subtract the union. A union B union C. So the formula is N of U minus N of A union B union C. So when solving problems, there are two methods actually. Either you can use formulas or you can use the diagrams. Now we'll begin with the exercise problem. Listen to me. This is the last exercise under first unit, that is 1.6. But remember, these questions are for 3 marks for the board exam. Statement problems will be there. You have to convert the statement problem to expression form. Okay? Now we'll begin with the exercise questions 1.6. Consider first question. If x and y are two sets such that n of x equal to 17, n of y equal to 23, n of x union y equal to 38. of x is 250, n of y is 200, n of x intersection y is to be calculated. Simplify, we'll get the answer 50. So the conclusion is 50 can speak both Hindi and English. Consider question number 7. In a group of 65 people, 40 like cricket, 10 like both cricket and tennis. How many like tennis only and not cricket? How many like tennis? See, two questions are there. One question, how many like tennis only, not cricket? How many like tennis? Okay. So now if you observe the statement, how many sets are there? 2 sets. Number of people related with cricket, number of people with tennis. Okay. See here. X denote the set of people who like cricket. Y denote the set of people who like tennis. So n of x, that is 40. N of x intersection y, 10. Number of people who like both cricket and tennis. N of x union y, that is 65. Use the formula n of x union y equal to n of x plus n of y minus n of x intersection y. Substitute the value 65 equal to 40 plus n of y minus 10. Intersection is given. So if we simplify, we get n of y as 35. This gives you the number of people who like tennis. Now another question, the people who like tennis only. So from this you have to subtract the intersection. So 35 minus 10 gives you 25. The same solution can be given using Venn diagram also. So let's consider that. 2 sets, so we need 2 circles like this. Number of people who like cricket, consider to be x now. Number of people who like tennis, consider to be y now. Then intersection is given, that is 10. N of x is given 40, 10 is there already, so this will be 30. N of x union y is given, that is 65. N of x union y, that is 65. See, 30 plus 10, 40, it is there already. Together it will be 65. So what is remaining over here? 25. Now listen to me. According to the statement, number of people who like tennis only is 25. See, the answer we got in the formula also, it is 25. So number of people who like tennis only, that is 25. Now listen to me. The number of people who like tennis, that is this region, that is set y. So that is n of y, that is 10 plus 25. That gives you 35. And if you observe the formula method, there also we got the same answer. So any method can be used to get the solution. See here, the same thing is represented using diagram. Union is 65, n of x is given, that is 30, intersection is 10. This is to be calculated, is n of 10 is only. Together 30 plus 10 plus a gives you 65. Simplify, we'll get number of people who like tennis, that is 35. Tennis only, that is a value actually, that is 25 from this expression only. n of x union y, that is the question actually. N of x is given, that is 50, 40 plus 10, intersection given, that is 10, then n of y also given. If we substitute in the formula and simplify, we get the answer 60. From the diagram, it is 40 plus 10 plus 10. Combining together, its union of 4 with 3 gives plus 100 plus 125 gives you 275. From the universal set, if you subtract that 275, that gives you 325, which denotes the students who take neither tea nor coffee. There is a correction in the mode calculation actually. 600 minus 275 gives you 325. Not 225, it is 325. Make the correction. So answer is 325. Number of students who do not take tea and coffee. Neither taking tea nor taking coffee. Next, consider question number 15. The statement is like this. In a survey of 60 people, it was found that 25 people read newspaper H, 26 read newspaper T, and 26 read newspaper I. 9 read both H and I, 11 read both H and T, 8 read both T and I. 3 read all the 3 newspapers. Find. 2 questions are there. First one, the number of people who read at least one of the newspapers. Second question, the number of people who read exactly one newspaper. First question, number of people who read at least one of the newspaper. Second question, number of people who read exactly one newspaper. Now listen to me. If you observe the statement, now 3 sets are there. Number of people reading newspaper H, newspaper T and newspaper I. See the diagram? R in circle. Number of people who reads newspaper H, then See, the statement is, see, the statement is like this. A college awarded 38 medals in football, 15 in basketball and 20 in cricket. If these medals went to a total of 58 men and only 3 men got medals in all the 3 sports, how many received medals in exactly 2 of the 3 sports? How many of them received in exactly 2 of the 3 sports? Okay. In all the 3, it is 3. But the question is in exactly 2 of the 3. That is to be calculated. So we'll use Venn diagram to solve this. This is the diagram for football, basketball and cricket. Total it will be 58 mentioned already. See, the equations are like this. A plus B plus D plus E, A plus B plus D plus E. That is total football entries, right? So that is 38. Consider A plus B plus D. A plus B plus D. That is 38 minus 3, 35. Next consider B plus C plus E plus F. B plus C plus E plus F gives you the basketball members. The one who got basketball award, that is 50. Simplify, we'll get B plus C plus F, that is 15 minus 3 means using this all the 3 values, that is 12. Next consider for this one D plus E plus F plus G, that is for cricket, that is 20. So subtract that all the 3. So 20 minus 3, that is 70. Now if you add all these data, total goes to 58. If you subtract that 3, all the 3 together gives you 55. Now the question is the number of people who received awards exactly in 2 of the 3. But this 3 appeared 3 times. You have to subtract that. So the answer is actually 64 minus 55, that is 9. 64 minus 55, that is 9. Which denotes the men who received medals in exactly 2 of the 3 sports. 2 of the 3 sports. Using the formula, the same question is solved. N of F union B union C equal to N of F plus N of B plus N of C minus your intersection of 2 each, N of F intersection B, N of B intersection C minus N of F intersection C plus N of F intersection B intersection C. This is the formula. Substitute the values. N of F is given 38, N of B is given 15, N of C is given 20. Then total it goes to 58, that is union, and all the 3, N of F intersection B intersection C, that is 3. It is mentioned already. So this is needed. N of F intersection B minus N of B intersection C minus N of F intersection C. So if you remove that minus as a common outside and shift that to the left side, that becomes like this. So 76 minus 58, add all the 3, then bring this to right side. 76 minus 58 gives you 18. But this 18 includes all the 3 entry, that is 3 times. You have to subtract that. See, 18 minus 3 into 3. Because we need exactly 2 who won the medals in exactly 2 of the 3 sports. 3 sports is not needed. 2 of the 3 sports is needed. All the 3 intersection is not needed. So subtract that. So 18 minus 9 gives you 9. So we